I have traversed the academia for the greater part of a decade, and I observe self-serving academics who never solve real problem, writing grant after grants, silencing dissents, and publishing papers, and just for the purpose of citations and promotion. Now, this has been the traditional academic metrics. Can you tell us how we can change from this narrative of publication and citation just to be promoted into commercialization and translational impact of our work, of our research work? How do you think we can make money out of our own work and then provide the necessary, benefit to the society, not just for the promotional sake? How can we do that? Now let's set the ball rolling. So, what can you provide a background as to your choice of biochemistry and why the particular interest in natural products?
Okay, thank you very much. My journey to the world of biochemistry or to studying biochemistry is based on my interest or passion for studying the chemistry of the biological system at the molecular level, which is the definition of biochemistry. And we know that studying the chemistry of the biological system has to do with going around studying molecules, studying their composition and how they interact with certain cells and tissues of of the biological system. So that is my interest. And I worked too on medicinal plants. We know medicinal plants are good substances that contain phytoconstituents that can play a role in ameliorating certain clinical or metabolic conditions. So those are my interests. And again, we know that there are quite a lot of diseases and ailments. And my interest in natural products and medicinal plants is hinged on the fact that through um, certain bioactive compounds from these medicinal plants, we can get healing relative to some clinical and metabolic conditions.
Current station of knowledge alludes that diabetes is more of a systemic metabolic disease, much against the classical understanding of diabetes, that sees it as a pancreatic issue. Now, what were your findings with lycopene in relation to managing diabetes?
Okay, diabetes, as we know, is a to me, I'll take it from the biochemical point of view as a metabolic condition because we know from the glycolytic pathway that um, if there is inhibition along certain key regulatory enzymes in the pathway, take for example hexokinase. If hexokinase is inhibited, the inhibition of hexokinase, which is a key regulatory enzyme along glycolysis, will make or will lead to accumulation of glucose, which will predispose to hyperglycemia, and hyperglycemia will further predispose to diabetes mellitus. So, inhibition of key regulatory enzyme along a biochemical pathway can lead to accumulation of glucose, which will lead to hyperglycemia and, of course, diabetes. So, from the biochemistry point of view, we see diabetes mellitus as a metabolic condition along biochemical pathway. Then another twist to it is this. If we look at gluconeogenesis, gluconeogenesis is a pathway that produces glucose. So activation of key regulatory enzymes along the gluconeogenetic pathway can lead to production or overproduction of glucose. That is the event that glucose is not being used up. So in such situation, glucose will also accumulate, leading to diabetes mellitus. Then we may have glucose being high, and if insulin is not there, or if insulin is not capable enough to take up glucose from the blood, that may also lead to type 2 diabetes and a spike in blood glucose level. Uh, Most of this processed food if ingested and digested, may lead to production of glucose. And if glucose is there in the body and they are not being taken up, they call it glucose uptake. If there's no glucose uptake, then definitely there'll be a spike in glucose, and that may leave the patient or the individual with hyperglycemia. So that is my place to it. Then for insulin, insulin, of course, is secreted by the pancreas, and it plays a role in regulating blood glucose level. So a damage to pancreas may leave us with um, production of maybe little or minute quantity of insulin. And we know if insulin level is low, like the case of type 1 diabetes, which is insulin deficiency, may also lead to inability to regulate the increased level of glucose and may lead to diabetes mellitus. The destruction of the pancreas can occur due to a lot of reasons. First, it can be due to ingestion of, or let me put it this way, induction of chemical product. Or let me use the word compound, because there are compounds we use in biochemistry and in other disciplines to damage, not to destroy. We use it to damage the pancreas. So when the pancreas is damaged, it limits the ability of the pancreas to secrete insulin. There are substances like streptozotocin. There are other compounds like allosan. So all those compounds are known compounds that can damage the pancreas in the ability to secrete insulin. Then autoimmune response as well. Autoimmune response, or let me just say the immune system. You know, immune system most times they fight against body cells they are ordinarily supposed to defend. All right, so that way, that could also lead to damage in the pancreas in the ability to secrete insulin that should regulate blood glucose.
Is high blood pressure a disease or an adaptive response to stress? Again, you worked on, I think you worked on beetroot. Can you provide us that biochemistry dance or the mystery behind, beetroot's use in controlling high blood pressure? Can you provide that chemistry background as to why beetroot is capable of lowering high blood pressure?
Okay. High blood pressure, to me, as a biochemist, is a metabolic disease because it's a condition that occurs as a result of activation of key regulatory enzymes along the cholesterol biosynthetic pathway. Now, let me explain further. We know that in the cholesterol biosynthetic pathway, that if the key regulatory enzymes are properly activated, that activation of all the key regulatory enzymes, especially HMG-CoA reductase, will lead to increase in production of cholesterol. That if those cholesterols are bad cholesterols like LDL, triglycerol, VLDL. So if all these cholesterols are produced, definitely there will be a spike in cholesterol content, which will lead to high blood pressure. So I see cholesterol as a metabolic disease. Then to this issue of adaptive response to stress. If there's slight exposure to oxidative stress, that slight exposure may lead to onset, may help to trigger the development of, may help to trigger the systolic and diastolic movement to rise. All right. Then, in a case where when we are exposed to severe stress, that can also, in a way, lead to development or onset of stress. Then, to the issue of beetroot, which I worked on, beetroot is a plant, is a natural product, and we saw from our research, from the preliminary study we did from beetroot, that it contains nitrate. And nitrate can be converted to nitrite, and nitrite can also be reduced to nitric oxide. And we know nitric oxide too can play that role to convert the substance to to convert that substance and play a role in relaxing smooth muscle. So that's
Again, you worked on moringa oleifera in the management of obesity. What is really obesity? And what is the relationship between obesity and inflammation? Again, can you provide to the viewers that biochemistry dance that orchestrates, you know, the lowering or reduction of weights of obese people using moringa oleifera?
okay. In that research, which we did on Moringa oleifera, we actually we actually induced high blood pressure in experimental animals or experimental models using high fat diet. After doing that, then we prepared Moringa oleifera extract into various doses and administered. And at the end of that research, we saw that the we saw that the lipid profile levels, which rose earlier, were reduced by Moringa oleifera. And we later concluded that Moringa oleifera at those doses played significant role in as hypocholesterolemic agent. Times when obesity are setting, most of the parameters of obesity are setting, most of the inflammatory markers too may spike, may rise up. Markers like nuclear factor kappa B may rise, and as well as other, even Mac B too may rise. So that is the relationship because they play a role in the development of fat cells. So like MACB, for example, play a role in the onset of adipocyte differentiation. And that adipocyte differentiation may help in the onset of fat development of fat cells. So that way, that relationship exists in the MACB playing a role in uh, building up of fat cells. So that way they are related.
I have traversed the academia for the greater part of a decade, and I observe self-serving academics who never solve real problem, writing grant after grants, silencing dissents, and publishing papers, and just for the purpose of citations and promotion. Now, this has been the traditional academic metrics. Can you tell us how we can change from this narrative of publication and citation just to be promoted into commercialization and translational impact of our work, of our research work? How do you think we can make money out of our own work and then provide the necessary, benefit to the society, not just for the promotional sake? How can we do that?
Okay. This is a very good question, and it is one that should bother all academics. A way that we can move from the lab to the field, or from lab to commercializing products of our research, is to actually collaborate. A biochemist or a physiologist or an anatomist or a med lab scientist can collaborate with a pharmaceutical technologist who is into converting semi-solid products from extract into useful product. That is after those extracts or fraction or nanoparticles have been ascertained at the preclinical level. So that biochemist or the scientist can collaborate with other people. Then that way, they can convert compounds or biomolecules that have useful product or are efficacious as per in vivo to probably to tablet and some other thing. But for we to commercialize and probably patent, we have to, of course, go through the normal route. An extract from plant has to go through preclinical trials. It goes through clinical trial. It goes through all the procedures, approval by the regulatory bodies, then production into tablets and other things. But my take here is collaboration. We can do that by collaborating. You may not have the money, but you have the knowledge. So you can collaborate with other people who have the money, who have the equipment. So that way we can thrive and convert our research findings from our research into commercial products that can help people out there in the community and the society. Okay. This is a serious matter that needs urgent attention. The way I see it is actually trying to create a niche for ourselves. But creating a niche for ourselves actually needs funding. All right. So no research work can thrive without fund. So every researcher who wants to create a niche for himself, who wants to probably become an institution, needs funding. But how do we get the funding? We know most of the government institutions are funded, maybe probably from the various funding agencies. But how about academic staff who are in private institutions? So funding is key. And apart from funding, sourcing for funds too. One can also source for funds to do these things because an average scientist in Nigeria or other African countries or other parts of the world, have these products, work with these products, and they get extra, they get fractions from products. But what of the funds you need? So ability to generate fund and attract funding to is key to creating a niche, becoming an institution, depending on your own, so that you can actually eventually get these products into the public to benefit members of the society.
And what advice will you give to a young, professional who is aspiring to become a biochemist, especially in your field of study, natural products?
Okay, advice for upcoming researchers and scientists who intends to pitch a tent in biochemistry is for you to actually have a focus, have because in biochemistry, for example, there are a lot of areas. So you need to actually pick an area of interest and work with people or collaborate with people who are in that area. You learn from them, and when you learn from them, you can actually thrive. So I advise young people coming up to do that. Align yourself with a senior person in that area. You learn from them. Then you also study very well. Study from of course, the internet is available for us to study. Study for the internet, and we'll be fine.